Hello everyone, my name is Ajay and in this section I'm going to discuss about the Azure Firewall, which is cloud native firewall from Azure. Comes with threat intelligence like features, and it has also inbuilt high availability functionality. It is used to inspect your traffic, which is basically east-west or north-south direction. And we are going to discuss each and every feature provided by firewall in upcoming slides. Whenever we discuss about the firewall, the basic functionality it always comes in our mind is going to be a device which is meant for traffic inspection. And when we are talking about Azure Firewall specific, it is a virtual firewall, or you can say a piece of software which is running on a VM, which is highly scalable and comes with many feature what you see in the next generation firewalls as well. It has high availability inbuilt and it can scale as per your requirement. You can control or basically put some sort of the perimeter or the boundary to protect your resources which is hosted on cloud. And when you want to protect your resources on cloud, you can go for two options. One option you go for the Azure native firewall, or you can go to the marketplace and choose the network virtual appliance. And there are vendors like Fortinet, Cisco, Sonic Wall, Checkpoint. You can go for and use those virtual appliances as well, which gives you this almost similar functionality. Now let's compare Azure firewall features versus the NVA. So if I go for the first one, which is going to be the FQDN filtering, FQDN filtering means if you know the FQDN, and if you want to block that particular traffic, for example, if you want to block the Facebook from your network, you can go for this kind of filtering. And this is supported by Azure Firewall, and it is also supported by NVAs. Inbound, outbound traffic filtering by 5-tuple rules. That's very common. It is supported by Azure Firewall and NVA as well. Then you have a SNAT and DNAT support. So SNAT is a source NAT and DNAT is a destination NAT. And as I mentioned earlier also, it also gives you the threat intelligence capability. You can also go for SIEM integration. It has built-in high availability. And when you go for NVAs, it is vendor dependent. So for example, I'm running my firewall piece on one VM, and if I put a skill set, it can expand as per my requirement. So that's called the VMSS feature. Then you have Azure Service Stack, that is Azure specific. Then you have integrated monitoring and management, zero maintenance, cloud service model, that is also Azure specific. And your DevOps integration, it does provide DevOps integration, and when you go for the NVAs, it is going to be the template based. SSL termination and deep packet inspection, that is a very common feature, and it is covered by both type of firewalls. Then you have traffic filtering rule by target, that is also something covered by both the firewalls. Central management, obviously these NVAs, for example, if you go for Palo Alto, a management platform which is called Panorama, you can go for that. And similarly, in Azure Firewall, if you go for that kind of management, you can opt for a Azure Firewall Manager services, which is free of cost as well. Then application and user aware traffic filtering, that is a capability it has got. IPsec and SSL VPN gateway, that is also something very common. You can create Azure VPN gateway and integrate it And here you can terminate those connections on your NVAs. When it comes to sandboxing, this is not there. And in NVAs, it is going to be the vendor dependent. The next feature we should be aware about DDoS protection, which you can implement with the firewall. So DDoS is basically as a kind of attempt to exhaust your network resources on the services for the genuine users. And these attacks are happening all the times. Here in the live screenshot which I have taken from the NetScout, you can see these many attacks are originating from locations and you cannot control it. So you need to put some sort of the protection plan in front of your cloud environment. So you can associate your virtual networks with DDoS plan, and that you need to do it from Azure Firewall Manager. There are three type of SKUs available for Azure Firewall. One is going to be Firewall Basic, second is going to be the Standard, third one is going to be the Premium. So when we talk about the Standard, these functionalities comes inbuilt. So you can go for the high availability, you can go for unrestricted cloud scalability, threat intelligence, web categorization, force tunneling, etc., etc. And you can further upgrade it to your premium, which gives you more functionality like TLS inspection, IDPS, and URL filtering. Top of that, upgrading from firewall from lower SKU to the higher SKU is a one-click upgrade. So you can upgrade it from firewall basic to your premium, or you can directly go for the standard. And if you're running on the standard, you can go for premium as well. Let's now talk about Azure Firewall architecture, and rest of the video I'm going to focus only on Azure Standard Firewall. So we can see spoke 1, spoke 2, and these spoke can talk to each other via this firewall. So you need to put this firewall in somewhere in a hub VNet. So it is going to be hub and spoke architecture, and this can be the communication established between the spokes. So this is going to be your east-west traffic. Similarly, this is going to be your north-south, which is meant to go for internet. And then obviously you are going to have the functionality to configure L3 to L7 firewall rules. And there's one more feature which is a kind of the feed which comes from Microsoft Threat Intelligence, that is basically a database which maintains about the malicious IP address and FQDN. And based on that feed, you can put your firewall into alert or deny mode. So whenever that traffic is passing through this firewall, this will be inspected against these dynamic rules. And based on the mode, whether it's alert or deny, your traffic can be triggered that way. By default, every traffic is denied. And the reason behind is not going to be any policy or any other firewall rule configured. Once policy is in place, traffic is inspected, it can pass through this firewall. And to make it work, you can configure SNAT or DNAT. So SNAT is basically your source NAT, DNAT is your destination NAT, and which we are going to discuss in couple of next slides. You can also use force tunneling on these firewalls. It means you're going to send your traffic to your on-prem. Maybe on-prem you have some sort of the firewall, and from there you have the internet connectivity. So you can use the force tunneling Or you might have some sort of the SD-WAN kind of NVA equipments where you want to pass this traffic. So this is another functionality which exists. Let's now try to understand use case of the firewall when you use in hub and spoke kind of the architecture. So putting this firewall into a hub VNet, there can be two purposes. Either you want to route this traffic which is coming from spoke to spoke, and same time you want to inspect any traffic which goes out to the internet, and that too from this firewall. Every VNet can have reachability directly to the internet. Means if this is a spoke VNet, if I want to go to internet, I can go from here. And similarly from here, I can go to this internet as well. But in a controlled way of managing this internet traffic, all the traffic from spoke, including if I have any resource here in hub VNet, it must go through the firewall first. And based on the firewall policy, this should be the exit. So let's try to understand the first use case. First, I want to speak between, or I want to talk between this spoke VNets. So this is a kind of the NVA. You see here, I need to establish the peering between spoke to hub, and then you need to put a UDR, and this UDR is kind of the routing table to reach 30 10.3.0.0. I can put a route towards this Azure firewall. Similarly, to reach another VNet, subnet from here, I can put a route towards this NVA, which is going to be the Azure firewall. And when this traffic reaches the firewall, I can put another policies also. If the traffic is meant for the internet, then there's going to be kind of the source NAT configuration which you need to do. And you can put your policies and control in place for any traffic which is meant to go to the internet. There is one more use case I see, and for example, if this is your on-prem, you might have some sort of the DNS server, and the people whosoever is sitting here, they want to use the DNS services. This is a private DNS, by the way, and they want to use these entries, whatever you have it here from on-prem. So this firewall can be used as a DNS forwarder. So here you can put an entry towards the firewall IP, which is going to be the private IP address. And this connectivity can be your express route, or it can be your IPsec, site-to-site VPN. And this firewall will have the proxy towards this DNS zone. And that is a way you can use all the entries here to your on-prem. You can also associate your firewall with Firewall Manager, and that is free of the cost. So what you can do here, you can create firewall policies, you can add security to your virtual hubs, and you can also protect your virtual networks. And that will be directly managed from the Firewall Manager. Let's try to understand the address translation. So the first thing is going to be the source network address translation. What it means, you are going to hide your resources behind the netted IP address. So for example, this is a VM. If this try to reach out to the internet, it can utilize the public IP address, which is basically allocated to your firewall, and the connection will be initiated on behalf of this. So there is going to be some sort of the NAT translation which will occur on the firewall. Similarly, another option is going to be the destination network translation. So for example, you want to hide your resources behind the firewall, and you want to utilize IP addresses which is configured on the firewall itself. So these are going to be the public IP address, hence the flexibility was given to you. You can add up to 250 IP addresses. So once you create a rule, users from internet, they will be hitting your public IP address on the firewall, and that will be translated back to your VM. Another thing is, which is very, very important, you need to keep in mind how these firewall rules are processed. Azure Firewall denies all the traffic by default until rules are manually configured to allow traffic, and that is what we have seen while discussing the firewall architecture. Rule collections are processed according to the rule type in priority order, lower number to higher numbers from 100 to 65,000. So we have seen NAT rule that is going to be processed first. After that, it is going to process your network rules, and then it is going to process your application rules. Targeted FQDNs is something you need to define, and FQDN tags is something which is specific to the Microsoft services. Thank you for watching, and I will see you in the next section.